last class we learned about our series, which if you remember, that just means you take your sequence, you add up all the terms. That is what a series is, just the sum of your sequence terms. So now we have various word problems dealing with our series applications, and you have to be able to figure out A, is it arithmetic or geometric, and then that tells you which formula you're going to use. So looking at our first example, we have a ceramic tile floor is designed in the shape of a trapezoid, 20 feet wide on the top and 10 feet wide on the bottom. The tiles, which are 12 inches by 12 inches, are going to be placed so that each successive row contains one less tile than the preceding row. How many tiles are required? So as I said, again, first thing you should be asking yourself is this arithmetic or is it geometric? Geometric. Nope, somebody whispered it. It's arithmetic because you're just subtracting. It's one less tile per row. So remember, arithmetic, that's your adding or subtracting one. So since it's arithmetic, what you should be thinking to yourself is our sum formula is S sub n equals n times a sub 1 plus a sub n all over 2. That's our formula we need to use. So in order to use that formula, the three things we need to know are n, our a sub 1, and our a sub n. So then we got to sit here and we got to think a little bit. We got to break down our problem. So up here is 20 feet. And our tiles are 12 inches by 12 inches, which is how many feet? 1 foot by 1 foot. So how many tiles are going to fit in my first row? 20. So our first term, a sub 1, would be 20. How many tiles are going to fit in my last row? 10. What's the one thing we don't know? We don't know how many rows we have. So we're going to go back to our old arithmetic formula that we've been using, our a sub n equals a sub 1 plus n minus 1 times d. We know our a sub n is 10. Our a sub 1 is 20. I don't know my n, so I'm going to leave that as an n. And what is our d? What are we changing each row by? But since it's 1 less, it would be negative 1. So now we can solve for n. I'm going to distribute my negative 1 first. So I get 20 minus n plus 1. So my 20 and my plus 1 give me 21. Subtract our 21 over, what do we get? And then divide by negative 1. Means our n is a positive 11. So we end up with 11 rows in there. So now we can plug into our sum formula. So S sub 11 equals 11 times 20 plus 10 all over 2. So let's have you go ahead and type that in your calculator. Let's see what we get for our sum. How many tiles are we using total? No. Uh-oh. Nope, only 111 there. No. You should. Okay. There it is. Alpha y equals. There you go, so 165 tiles. So our next one, we have the Clinton Theater has 25 seats in the first row and 30 rows in total. Each successive row contains one additional seat. How many seats are there in the theater? So this right here, how many seats are there in their theater is telling you We're looking for the sum. We're adding up each of the rows. So again, you have to think to yourself, are we talking arithmetic? Are we adding something each time? Or are we talking geometric where we're multiplying each time? If each row contains one additional seat, are we adding or multiplying? Adding. So this one again is arithmetic. So once you can figure that out, then you know which formulas to use. So our ultimate goal is to find the sum. So I'm going to write my sum formula down. The S sub n equals n times a sub 1 plus a sub n all over 2. So let's see what we know. Do we know our n? How many rows we have? How many rows do we have? 30. Do we know how many seats are in the first row? Yeah, 25. Do we know how many seats are in the 30th row? No. So we got to figure that out first. So again, we still have to use our other formula. Our a sub n equals a sub 1 plus n minus 1 times d. We're looking for our 30th term, so a sub 30. 25 plus 30 minus 1, and our d would be a what? 1, because we're adding one seat for each row. Yep, so row 30 has 54 seats. So now we can plug that into our sum formula. Yeah, the sum formula is the one you have to remember for arithmetic. All the other ones you're given.
Oh, okay, so we're given the one first.
You've got to memorize this one. You're given that one. No? Oh, what'd you get? Should be a big number. Yeah.
So that's how many are in the 30?
In the entire theater. That's adding them all up. That's how many seats are in there total. So if they were having like a musical or something, they can sell 1,185 seats.
Okay. So for this take-home quiz.
Nope, not talking about that yet. All right, so next one, we're going to revisit the pendulum problem we dealt with before. We have our pendulum that swings through an arc of 18 inches. On each successive swing, the length of the arc is 0.98 of the previous length. So we have to ask ourselves again, is it first arithmetic or geometric?
Geometric.
This one's geometric. Each swing is being multiplied by your 0.98 to find the length of the next one. And then times 0.98 again, and then times 0.98 again. So they want to know, after 15 swings, what total distance will the pendulum have swung? So now we have to use our sum formula for our geometric series, which would be our a sub 1 equals 1 minus r to the n power all over 1 minus r. So let's figure out what we know, see what we need to find. What is our n? Our n would be 15 because there's 15 swings to the pendulum. What is our a sub 1? What is the length of the first swing? 18. And our r, what are we multiplying times each time? 0.98. Do we need to know anything else for our formula? Nope. We know everything. So you just got to remember, your geometric series, you don't need to know what the last number is. Only what the first one is. So when you plug everything into your formula, 18 times 1 minus 0.98 to the 15th power, all over 1 minus 0.98. we're going to round to the nearest tenth.
I forget off the line all the time.
Huh? Sounds about right. Does anybody disagree or agree? Nobody's contesting you, Amir. We got an agree. All right. All right, let's take a look at our last question on the back. All right. So we have Mike has started out the year in Algebra 2 slowly, earning test grades of 48, 50, 52, 54, but he is progressing. So they want us to write an explicit expression for this sequence. So we got to figure out, are we dealing with an arithmetic or a geometric sequence?
Arithmetic.
Arithmetic. So we've got to use our arithmetic sequence formula. So our first term is what?
48.
Yeah. Our D is
2.
2. So now let's distribute our 2. So A sub n equals 2n plus 46 when you combine things together. Because this would have been negative 2, so 48 minus 2 gave me my 46. Now some people just like to just jump to this and they remember that this is like a linear equation where you've got your slope and your y-intercept. If you want to do it that way, that's fine also. Whatever gets you there. So part B, what will Mike score on his 15th test? So A sub 15 equals 2 times 15 plus 46. That will give us a score on his 15th test. 76. Yes, he is. So we will take 20 tests over the course of the year. What will be his total for his test scores? So they want us to find the sum of his test scores. This is the one you have to remember, yes. So S sub n equals n times A sub 1 plus A sub n all over 2. Do we know his 20th score yet, though? No, so we got to figure that out first. So again, using our formula from part A, plug in a 20 this time. His 20th test score will be an 86. So now we can plug everything in. Our n is 20. His first test score was an 84. Was a 48. His 20th was an 86. All over 2. So what's the sum of his scores? 1340. So all 20 of his tests, if you add them together, you would get 1340.
That's a lot of tests per year.
Yes, I agree. All right, last part. What will be his average test score? How do you find the average of anything?
Add them up and divide by the amount.
Add them up divided by the amount. We already added them up. Was 1340. So divide by 20.
Sorry.
What?
Let's say 48 plus 86.
Yeah. What was his average?
67.
67.